In this video, we will be showing you how to set up streams and also how to set up subscriptions in TDengine. I'm just going to log into my TDengine Cloud instance. If you recall, in the last video in this series, we had set up an OPC data source. That data source is ingesting data into this table called Solar Farms OPC, actually this super table I should say. And as a reminder, the way that this table is configured is as follows. This is the name of the measurement. This is the site, the string on which the panel is, and in the panel ID, and then the timestamp of the measurement, the quality that's coming from the OPC server, and also the actual value, which is a floating point. And in this video, what we're going to be doing is we're going to be looking at the power output from each solar panel, and we will aggregate that for the prior 5 minutes. And for that, we'll actually use a stream. Now you could of course do that at the application level, but TDengine is far more efficient at performing computations on time series data. So using streams in TDengine allows you to take advantage of the computational power of TDengine. So in order to create that stream, I can click on streams, click on add new stream, and give your stream a name, and then choose the output database. In this case, I'm going to choose renewables. I'm going to give the super table a name just for simplicity. I'll call it P5. And then my source for the data is also the same database. My super table is called Solar Farms OPC. And then this is where you can actually choose the columns that you want. I definitely want the timestamp. I don't want the quality. You could do something with quality if it was relevant in your case. Just for simplicity here, I won't have quality there. I do want the site, the string, and the panel ID. I don't want the name in this case because I'm actually going to filter by the name. I'm going to say my name, confirm that. And then I'm going to be sampling at 5-minute intervals. And I'm not going to trigger every single time because that will give me the data for every single second. But what I want is when the window closes. And what this does is, I forgot to give this stream a name. And now this generates the SQL for me. I'm just gonna have us take a look at it. So you can see it's creating the stream. This is a name, trigger on the window close, and then into this super table. And then it also has the select query. I want to do a little more with this. I've actually copied that SQL in here and I've added some additional stuff because I want to have the string and the panel ID as columns in my results super table. So let me just copy that. And then I'm going to just run this in my SQL Explorer and create that stream. So now I've created that stream. I should be able to see that stream here, and you can see that this stream is ready. And it should also have created the P5 table for me. And yeah, you can see that it's here. We can look at the configuration just to make sure it's what we wanted. So yeah, it has a timestamp, the average power, the string, and the panel ID. And then this group ID is something that TDengine inserts into the super table as a tag to be able to distinguish between the subtables. In my case, since I have the string and the panel ID as columns in here, I am able to query it as I wish. I am going to go ahead and query this really quickly just to see that there's, so we should see some data in here. And as you can see, there is data over here, and it just gives me an average over the last few minutes for all the panels and strings and the panels within those strings. But now we want to do something more interesting with this data. We want to see if we can set up some alerts if the power output of a panel falls below a certain threshold. In this case, I'm going to say 10. And what we want to do now is figure out how to set up an alerting system using TDengine and of course some other application code. But TDengine makes it quite convenient to set up something along these lines because TDengine does have the concept of pub/sub, or subscriptions as we like to call it. And the idea here is that you should be able to get the columns from any database or super table or table at a very granular level and share that data with a consumer. That consumer could be code or it could be a person. The nice thing about topics is that it gets to a very granular level because you're essentially writing SQL. So let's see what that looks like. I'm going to give that topic a name. The database is going to be renewables. I'm going to do a subquery on the super table P5 where we're storing the power in 5-minute intervals. And again, here I can select which columns I want. I definitely want the timestamp. I want the average power. And I do want the string and the panel ID because I need to know exactly where that panel is. And in this case, we're going to set a threshold of say 10 for the average power. If it falls below 10, then I want a message to be sent to this topic. And I can look at the SQL here just to make sure. And that looks right. I'm selecting the average power, the timestamp, the string, and the panel ID. I can confirm that, and then I can hit create. So now this has been created. And now what I can do is I can go to the sample code here, click on Python, and see what I need to do. You do have to configure some environment variables if you're running on Linux or no matter which system you're running on. This is for the bash shell, as you can see. And then this kind of walks you through how to create a consumer, and this is the full code. In this case, we're just printing the data and printing the number of rows and columns that we're getting. But what we can also do is obviously do something more interesting in your application code. So in this case, what we're going to do is we're going to send an SMS to my personal number using the Twilio API. I've actually already written the code. You can see that code over here. And I'm importing the Twilio API over here. And there's some information here such as the account SID and the auth token, which you would not have in your production code, of course. You would typically have that in a vault or in a configuration file, which is excluded from your repositories. And then all I'm doing here is I'm getting this information and saying that in this string and in this panel, at a certain time, the power was whatever the value is. So the way I simulate the power dropping to below 10 is that I've set the panel 0 and string 0, the power output on that particular panel, to go near 0, and then the average should drop over time. And you can actually kind of see that over here. You can see the value is 33 over here, and if I reload that, you can see it's gone to 0.009. And so I'm gonna start my alert script here, and we should see those alerts showing up shortly. And while we're waiting for the alerts to show up, we can take a look at the Explorer and see that I just ran this query, and you can see that at 8:40, this is UTC, the average power was 30. So I ran this query for the last 15 minutes. So we do have 2 data points here for string 0, panel 0. And at 8:35, this is UTC, the value was 32, and at 40, the value was 30. And we should see some more data coming in when the window closes, which would be at 8:50. And so you can see that at 45 it's definitely dropped here, and so now we should see an alert here. And if I look at my messages, I have a Twilio trial account, and you can see it did send me an alert on panel 0, string 0 at 1:45. This is the beginning of that window. The average power was 0.009. And this is how you set up subscriptions and streams so that you can create some pretty powerful applications in a very simple way without having a lot of different systems such as Kafka or some external pub sub system like RabbitMQ or something else. And you can use messaging APIs to make a pretty good alerting system at a very granular level.